outline very briefly some current projects that are underway that I think are interesting and actually rather exciting examples of different approaches to the philosophy that I've now outlined. The third example I have is a package called H2O, as in water. And my interpretation of the basic ideas behind this are that they have a substantial amount of code, mostly Java-based, which has been carefully designed and optimized for dealing with big data, seriously big data. There are a number of techniques built in. The first thing that they've done is to provide a data structure, a Java-based data structure, which is highly optimized for compression and for efficient processing. So the thing that would look like a data frame, it is a data frame for all purposes, but in this form will be stored in quite a different way. It's stored off somewhere else, not in R, not in memory. And then from that structure, or object, let's call it an object, statistical computations can be done. And the software that they have in the H2O package makes a great deal of use of Hadoop, the general MapReduce idea, and implements a number of the more recent techniques for clustering and model fitting. Informs that, at least from the examples I've been shown, are really strongly efficient in terms of what we can do in any obvious way ourselves. So again, this I think is important in the sense that we're making real use of the idea of the interface, the idea that there are objects elsewhere for which we have our objects that act as proxies. So the way I tend to describe interfaces is that you want to deal with our objects in our code and realize that those are proxies for objects or data structures that are held elsewhere and computations that are done by other processes. So it's really, really neat, and the people who are producing it are very keen to have people try out new ideas and other kinds of analysis. Again, as with LLVMs, relatively recent, maybe not as recent as the LLVM part, but the H2O package itself is on CRAN. There's a great deal more to the software than the package, and there's a menu-based environment and other kinds of things. But again, as with all three of these, the thing to do is, if you're interested, if it sounds like this might be useful for you, go to the web, go to the sites and find out more about what each of them is doing. And so let me just try to summarize what I think the implications are for this general idea of interfaces for these different examples. So RCPP and its modern version generate interface calls to C++ with less programming than the .call, in fact, much less programming than the conventional .call. So that means that you have available, first of all, potentially vast resources in terms of existing libraries in C++, but also you have an interface to a mechanism for programming in C++ yourself and making use of other software that may require a little bit more work on your part. And that's aided by having a set of programming tools and enhancements of C++, making a lot of use of modern things like template programming in that language, which in fact, as I see it, creates a modern version, much improved version of the interface language, which in this case is based on C++. So the LLVM for our examples, specifically the idea there is very focused. It's that you will compile our language code and suitable idioms of the R language into specialized forms for either efficiency or perhaps for other goals as well. And with the H2O package, again, the key points are that you're dealing with data in a different form. The data objects you're dealing with are not R objects. They're compressed and highly efficient versions of certain specialized classes, specifically the data frame class of objects in R. And that using that data structure, you can then make use of existing interface to functions corresponding to R functions, but written in a very efficient, compressed form, making use of particular computing models, specifically Hadoop, that will do certain computations very fast. So those, I think, are three. Now, it's very important to say that those are not all. There are lots of others, and you've been hearing about, or will hear about some of them in these talks. So there are lots of good approaches to this general philosophy of interfaces that I'm promoting. And I think, again, the bottom line is we need to use whatever is the best approach for a particular issue. So actually, it just turned out after the fact that those three examples rather neatly correspond to interfaces, efficiency, and big data. So I thought my title was well chosen. So this is basically what I wanted to say. Interfaces are an integral part of R. They always have been. If you want to deal with big data, if you want to deal with intense type of computations, be prepared to explore wide. Be prepared to look to see what's good. There's lots of useful new approaches to interfaces around. Anybody who feels inclined and wants to work on extending them or developing new ones, believe me, it's a very valuable area to contribute to the community. And my feeling is, that it always has been over the years, is that the best future is not uniformity,